This is Lesson 1 of Unit 4, Part 1, Interpretation of the Derivative in Context. So we are going to talk about related rates and contextual applications of derivatives in this unit. So we're going to start with some things that should be familiar to us from what we've been doing earlier in the year. So we're going to talk about being able to interpret the meaning of the derivative in a verbal way so that we can answer AP questions that ask us to explain what the meaning of the answer is. So that's the purpose of this lesson. So to look at some mathematical history, when Newton was developing his ideas of infinitesimal calculus, he called it a fluid. We call it a function. He called it its fluxion, which was actually derivative. Now, we've developed our terminology from the German mathematician Leibniz and his notation as well. Newton was focused on velocity and finding the position of planets relative to their velocity and where they should be. But Leibniz was looking at it in a more theoretical way. So he came up with y equals f of x, and then he expressed things as dy dx. So we can think of d as a small difference in some process, and we want to remember that because we're using a fraction or a ratio, it is the limit of ratios in the familiar form. And there is our familiar form right there. We have our dy dx is the change in y values or the change in x. So I know it comes up sometimes, what does d dx mean? It means the derivative of our function with respect to x. So d dy or d dx f of x is the derivative of x, the derivative of y with respect to x. Okay, now as we know, writing dy dx can be a little cumbersome. It's easy to write like f prime of 3, but it's easy for us with the Leibniz notation to be able to talk about exactly what something like dy dx at x approaches 3 means. So for example, our first example, Sean is cleaning out his salt water tank and needs to drain some of the water in order to adjust the saline levels. If the volume of the tank V is in gallons, is being drained over time, t minutes, what is a meaningful interpretation of the following statement as it relates to Sean's fish tank? Okay, so what we see here is we have dy dx, so our dv dt. And that is really just our v prime of 3 in this case. So what exactly is this telling us? Now remember, this is a rate of change. At t equals 3. So our meaning is going to be this, that since v prime of 3 is negative, we want to go back to what's happening with the tank. We're talking about a fish water tank, and we're talking about the amount of water, the volume in the tank. So since it's negative, water is being drained from the tank. So we have a negative rate. So what we would say is at t equals 3 minutes, the fish tank is draining at a rate of 2 gallons per minute. You want to make sure you have the right units for everything. Okay, so that's our first example. All right, using meaningful variables. Just like any other language course, we need to use proper names, spellings, and grammar. AP Calculus is no different than an AP language course. So you want to make sure that whenever you're writing a function and you're labeling it, you should use good, meaningful letters to label it. So there are many real-world functions that depend on variables other than x, y, or time. So learning to read and write these will help you really succeed on the free response questions in our course. So example 2. Read each scenario and write the proper notation for the derivative. So the first one reads, the Alberta tar sands are one of the biggest oil reserves in the world. Yet extracting the fossil fuel costs more than the profits made. If the cost C in dollars to extract a barrel of oil is losing $3 for every barrel, write the derivative. Now, some things we want to remember is we're talking about cost, and we're talking about losing money, okay? And so it's cost and barrel. So that's how we want to look at this. So our C is really going to be an F of B, where C is cost and B is number of barrels of oil we're making. Okay, so our derivative is going to be dC dB, and that's going to equal, and you want to make sure you give it the correct sign, -3. Okay, and you can include the dollar sign, and you can put per barrel. And you can also put that as our F prime of C. So however you want to write that. But this is the best way, right there. Okay, letter B. The Deepwater Horizon oil spill is regarded as one of the largest environmental disasters in American history. The oil leak was discovered on April 22nd, 2010. BP originally estimated that the flow rate was about 790 cubic meters per day at the end of the first week. So we have a positive number because we're pumping it into the ocean. So that's going to be a positive derivative. So if we let our V, our volume, because this is a volume measure, so cubic meters is a volume measure. So V is going to be F of T, where V is our volume of oil. And T is our time, and this is going to be in days, because it says per day there. Okay, so our F prime of 7 is going to be our dV dt, and this time we can put exactly where we're finding this derivative. It was vague in the first one. It was just a generic value. So this is at a specific time, 7. So this is going to equal 790 cubic meters per day. Okay, next example. The population P of an endangered mountain gorilla has an ongoing study tracking the number of gorillas since 1992. The population increased, that makes it a positive derivative, by 114 gorillas during 2003 of the same study. So we're going to use P for population since they use population, and that's going to be our F of T. So P is population. And this time, T is going to be time in years, because we study the population year to year. So we have to figure out how many years have gone by. So we have 2003 minus 1992. That's going to be 11 years. Okay, so we're going to do F prime of 11 would be the same as saying dP dt at t equals 11, and that's going to equal 114 gorillas per year. Okay, next example. Now we're going to read some meaning of some notation. This time we're given the notation and we have to interpret what it means. So, suppose a planet is discovered in 2024 and is named Newtonia. If in The alien population P of T is recorded in millions of aliens, and T represents the number of years since the planet's discovery. Explain the meaning of each statement below. Okay, so in the first one, letter A, we have that T equals 3, so that's going to be 2024 plus 3, so that's 2027. And our rate is 0.5, and remember, it's going to be millions of aliens per year. So that's the statement we're going to write. So we're going to write in 2027, the increase, because it's a positive number, in the alien population on Newtonia is going to be 500,000 people. You could write 500,000, not people, but I guess they're aliens, per year. Now you want to make sure you put per year because it's the derivative. Next one. So now we have the inverse. So we're doing P inverse 7.5 equals 5. So this is now our T. There's our T. So it's going to be 2024 plus 5. So that's going to be 2029. And the 7.5 million is our population. So we're going to, since it's the inverse, we're given the opposite. So in 2029, the alien population on Newtonia is, you can put 7.5 million or 7,500,000. Okay, and then finally, now we have an inverse, but we're taking a derivative of the inverse. So it's going to be the derivative only backwards. So it's going to be year per alien. Okay, so it's kind of backwards. All right, so we're going to see this time that there's been 7.5 years. Okay? No, I'm sorry. That's not true. The 7.5 is going to be our population. And the 0.75 is the change in the population. So when the population of Newtonia is 7.5 million aliens, it takes 3/4, that's where the 0.75 comes in, 3/4 of a year for an increase of 1 million aliens. See, now this is going to be the opposite, because before it was aliens per year, and now it's 0.75 years per millions of aliens. Okay, I'm going to stop here. This is a short section, but I don't want this to get too long, so we'll stop here and finish in a short video after this.